Yo, so for the folks that have been wondering exactly what do I need all this lab equipment for, well, the short answer is it enables me to test and characterize off-the-shelf and OEM embedded circuit designs to better understand how do they work, uh, how do they perform at the boundaries, and uh, validate that the data sheets are correct, that the system in its entirety is working as intended, and yeah, better set the working conditions and eventually improve on the design eventually. Because yeah, if you want to improve something, you need to know exactly how it works. And since we all know that things in theory never quite work the same in reality, well, this gives you exactly the controlled environment to test these circuits in real life situation. So here is a pretty neat use case that I'm currently doing. So yeah, let's go over it. So I have this 18650 charger and booster module. So this takes two 18650 cells and outputs 12 volt. It also has a USB-C charging circuit and over discharge, over current, over voltage protection, all in one single board. And I have it, instead of powering it with 18650, I have it powered on my programmable power supply. So right now it's outputting 4.2 volts to simulate a fully charged 18650 lithium ion cell, and it's pulling 1.8 amps. And why is it pulling 1.8 amps? Well, because I have the output loaded with this electronic load that is pulling 0.5 amp, so half an amp, and you can see that it's receiving 12.6 volt, a little over it, which is conform with what this board is supposed to be outputting. And yeah, so now we have control over both the input and the output of this system, and also have the IR camera set up to monitor the temperature, because as we reach the boundaries of this system, it's going to heat up. So I want to find out exactly how does that affect the whole thing. And yeah, so from there I can simulate quite a few conditions. So for instance, I can load it up with more current, more draw. That's gonna help me figure out exactly what's the limit, how much it can supply. Like, does it have an over current protection on the output, and at what exactly which current does it trips? That's gonna, with this IRCam, I'm going to be able to figure out exactly which components get the hottest during this process. Does it stay within margin, or does it get dangerously hot below what it's rated for? And on the input side, we'll be able to simulate how does the whole system works as the battery, for instance, goes down in voltage. Right now it's emitting a fully charged battery, but how would it do as we get lower? Yeah, some lithium ion can be discharged down to 2.5 volt, so that's going to require more current to bring that up to 12 volt. And yeah, so as the battery drains, how much current does it pull, and how does that affect the output voltage? I can also test the charging circuit with this, so I can understand exactly when does it start charging, or the over discharge protection, sorry. So I can see below which voltage does it actually stop pulling any current from it, and does it shut off. So yeah, this setup here allows very flexible environment to test all the vital features of power circuits. And right now I'm not even using the scopes because this is the way I'm planning to use this circuit. Doesn't quite need specific requirements that the scopes will help with, but I could totally use it, plug in the scopes and measure, say, the ripple voltage, see if there is any, figure out exactly the switching frequency, find out exactly how efficient this circuit is working. So basically with these four test equipment enable me to figure out a lot of my daily use. So I have the power supply, linear programmable power supply. I have an analog scope, digital scope, and the electronic load to cover all these use cases. And that's why it's all there.